Hello everyone, in this video we're going to go through section 2E, which is on matrices. So matrices aren't a very big component of the methods course, but it's still good to know how they work, and you can actually use them in different, we'll see them again, in different parts of the course. So this video is basically just focusing on the basics of a matrix, or the plural is matrices. Okay, so a matrix is just a rectangular array of numbers. So you can see there we've got two examples, and they can be quite big, or they could just be a single number. But every spot in the matrix has to have a number. You can't have a matrix like this first one. Where's my pen? This first one here. Oh gosh, sorry, I was about to highlight it. Didn't have the highlighter. This one here, see how we've got the 0? You do have to write a 0 in there. You can't just leave it empty. When we're doing, actually I'll go through the notes in the order. So this first one is a 2 by 2 matrix. So basically 2 rows, 2 columns. The second one is a 2 by 1 matrix. So 2 rows, 1 column. We always say the row first. So the row first, column second. So sometimes you will see a question. It says it's a 2 by 1 matrix. That's telling me that it's 2 rows, 1 column. Let's do one that we don't have an example for. So a 4 by 5 matrix has 4 rows and 5 columns. Whoops. Oh gosh. I don't know what happened there. Can I just... Oh gosh. There we go. Well, I think my computer's glitching. All right, we'll see how we go. 5 columns. So that means we have 20 entries in total. So 4 times 5 gives us 20. Now your entries, usually we call them elements, not entries. So the elements are just the numbers inside your matrix, and they have a specific position. You can see here, with matrix A, we usually use a lowercase letter to represent the element, so that if it's matrix A, we use lowercase a. If it's matrix K, we use lowercase k to represent the element. And then this number here is 1, 1, so that just means it's in row 1, column 1. And then A1, 2, row 1, column 2, and so on. All right, now adding, subtracting, and multiplying by a scalar are the easiest parts of matrices. Now, when you're adding and subtracting, they have to be the same order. So I've got it here. So when adding or subtracting matrices, they have to be the same order. So what I mean by order is they have to have the same number of rows and the same number of columns. And I just realized I've just said what the next sentence says. Okay, so if we had, let's just do a quick example because it's actually not that difficult to do adding and subtracting. So I'm going to just make one up. All right, I'm going to add that to a matrix. It also has to be a 2 by 2 matrix. So we've got 0, let's do 3, -10, 5. So when we're adding them together, you do have to add the same element. So the 2 and the 0 are added together. So 2 plus 0 is 2. Then the -1 plus the 3 is also 2. 5 plus -10 is -5. And 3 plus 5 is 8. So quite simple to add them together. They do have to have the same order though. All right, and if we were doing subtraction, same thing. Now, scalar multiplication is different to, oops, there we go, I've got an example down here. Scalar multiplication is different to matrix multiplication. So scalar just means we're multiplying it by the matrix by a number, a scalar. So if I wanted to double a matrix, we're just multiplying that matrix by 2. So let me just make one up again. So the scalar multiplication just means whatever number is out the front, everything inside it gets multiplied by that. So 2 times -1 is -2, 2 times 3 is 6, 2 times 2 is 4, and 2 times 4 is negative 8. All right, so there's your scalar multiplication. So adding, subtracting, and scalar multiplication, not too tricky with matrices. Multiplication of matrices, though, is quite confusing. So I'm going to go quite slowly through this. You can also do matrices on your calculator. So I might just quickly show you where you get your matrix up. So just this button here will create the values in how many columns. So this is 3 columns, and then you can go down. So that's 2 rows, 3 rows, 4 rows, and so on. If you needed to delete it, you can just go, don't know what you can go because I'm just pressing Control Z on my calculator, on my keyboard, but whoops, let me just go back, delete that. You can just get a 2 by 2 matrix quite quickly, and then you can expand on that. All right, so it's just pressing those buttons. Just make sure you've got a number in each spot. So you just use your cursor or your stylus to press in the spot. So you can have 4, 5, that's 3, 1, etc. Now, if you don't have a number in there, it's going to give you an error. All right, so just remember you need a number in each spot. All right, so I'm going to do matrix multiplication now. Oh, okay. I might do 2 examples. So let me do I might do a 2 by 3. So I probably should choose different numbers. Let me just choose a different number here. Okay, so I just chose 1, 2, 3, 4, 5, 6. Now, this is a 2 by 3 matrix. With matrix multiplication, you can only multiply a matrix if it has the same number of columns. All right, so the number of rows is the same as the number of columns in your first matrix. So if I was to multiply this, whatever the matrix I multiplied it by, I would have to have, because there's 3 columns in the first one, it would have to have 3 rows in the second matrix. So let me just do 2, 4, 6. Now, it doesn't matter how many columns this second matrix has, as long as it has 3 rows. So I might make it just a 1, for now, a 3 by 1. All right, so these 2 numbers have to be the same. Now, the easiest way to check, and we call it whether it's defined or not, is we can just say, all right, the order of the first matrix is a 2 by 3, and the second matrix is a 3 by 1. Now, circle these 2 middle numbers. So and the order does matter. All right, and I'll explain that in a sec. So we've got a 3 and a 3, they're the same. That means it's defined. We can actually multiply it. Now, your product matrix, what we get when we multiply these 2 matrices together, the order is going to be, well, whatever numbers are left on the outside. It's going to be a 2 by 1 matrix. Okay, so we can take the product of that. Now, if it was around the other way, so if we did the green matrix first, so let's just write the order. So it's a 3 by 1, and then the other one is a 2 by 3. All right, so we'll circle those 2 middle numbers. They're not the same. Okay, so we can actually not multiply them. What we say, it's not defined. All right, so your order does matter with your matrices. So it's not like normal multiplication where you can do 5 times 2 is 10 and 2 times 5 is 10. All right, so with matrices, when you're multiplying, the order does matter. All right, so what we do is we go across. Actually, I might do that in a different, I'm going to make it a thinner highlighter. Okay. So we go across, multiplies down. So we're going to have 3, 2, 1 times 4, 2, 6. And remember our product matrix is 2 by 1. So 2 rows times 1 column. All right, so first of all, I'm going to have 3 times 2 plus 2 times 4 plus 1 times 6. Okay, so 3, 2, 1 multiplies 2, 4, 6. So your 3 goes with your 2 with your 4, and your 1 with your 6. All right, so once you've done the first row, then you move on to the second row. So we're going to do 5 times 2 plus 4 times 4 plus 6 times 6. All right, so then you have to add these, or multiply them and add them up. So we've got 3 times 2 is 6, 2 times 4 is 8, 1 times 6 is 6. So what's that, 20? Then we've got 10, 16, 36. So what's that, 26, 56, 62? And you can always check, is it a 2 by 1 matrix? Yes, it is. 2 rows, 1 column. Now that was quite a straightforward one, just because I had 1 column with that green matrix. So let's do another example that's a little bit harder, and I don't have much room. Where can I do it? I'll just do it over here, maybe in a different color. All right. What did I have? A 2 by 3 before. All right, I might make this one a 3. So let's make it 1, 2, 3, 4, 5, 6. And you can have negatives, so let's do some negatives. You can have a 0 as well. All right, so the order of this purple matrix is a 3 by 3. Don't worry about those practice questions for now. And let's do a pink. So we've got pink. Oh, and they might be too close together. All right, let's do yellow. All right, so if I've got a 3 by 3, that means my next one has to be a 3 by something. So I might make it a 3 by 2. So 1, 4, 0, -1, 2. And you can have the same number. So let's do a -1 again. All right, so it's a 3 by 2. So you can see that can be done. So I can multiply them, because when you think about their order, we've got a 3 by 3 and we've got a 3 by 2. So if I circle them, they're the same. Yes, it's defined. And then our product matrix is going to be a 3 by 2 matrix. Okay, so it's going to look like this yellow one. All right, so remember we go across and then down. So kind of think about it if you're jumping off a diving board. So you run across the diving board and then you go down. All right, now we might not have much space here. So we're going to do the first row, first column, first row, second column, and then we move on to the second row. So we're going to have, I might write it up here. So 1 times 1. So this one multiplies this one. Then 4 times 4, so plus 4 times 4. So this 4 multiplies this 4. So remember we go across, down. -1 and 0. So you can do this in your head as you go, but I'm just showing you where the numbers actually come from. So we did the -1 and the 0. All right, then we go on to this second column. So we'll still stick with this row until it's multiplied each column. So we're going to multiply the second column now. So it is another element, so I'll just do it separate to the previous one. So 1 times -1 is -1. 4 times 2 is 8. And then -1 times -1 is +1. So instead of writing it out like I did the first element, I'm not going to do it for each one, otherwise we'll be here forever. All right, so I've done the first row now. I'm going to move on to the second row. So we've got 2 times 1 is 2, 5 times 4 is 20, and 0 times 0 is 0. And then we've got second row, second column. So 2 times -1 is -2, 5 times 2 is 10, and 0 times -1 is 0. All right, then we move on to the third row. So we have 3 times 1 is 3, 6 times 4 is 24, -2 times 0 is 0. And then last one, so third row, second column, 3 times -1 is -3, 6 times 2 is 12, got my plus sign, and -2 times -1 is 2. So that is a matrix. I'm going to just draw it, it's quite big. But these are our elements in our matrix. I just have to add them together. So 1 times 1 is 1, 16, and then 0. So it's going to be 17 here. Then we've got 8, 22, is that 8 again, 27, and 11. So you can see it's a 3 by 2 matrix, which is what we were expecting. Okay, so matrix multiplication is hard to do by hand, but you just go row, column, until you've done that row by every column. And then you move on to the next row. But much easier to do on your calculator. All right, so for 2E, we've got 2 matrices here. Part A is pretty easy, so I'm going to move on to B. So we're just going to multiply A and B. All right, so there's matrix A. Let's multiply it by matrix B. All right, so remember, row first times the column. And then we do that row by that column, second column. All right, so 2 times -2 is -4. 1 times 3 is 3. Move on to the next element. 2 times -2 is -4. 1 times 2 is 2. 3 times -2 is -6. 2 times 3 is 6. And then we've got 3 times -2 is -6, and 2 times 2 is 4. All right, so we've got -1, -2, 0, -2. Now I might just quickly show you on your calculator. So you can just get the 2 by 2 up quite quickly. 2, 1, 3, 2, and we're multiplying that by -2, -2, 3, 2. Right, so you can see there's your answer. All right, BA you can also do, but I'm not going to do every single one of them. So yeah, question F, you're going to have to do 2 lots of A first and then 3 lots of B and then add them together. So you can't add them together and then multiply them by 5 or 6 or whatever you think you might have to do. So let's do F. All right, so 2 times A, so 2A, so basically we're multiplying this whole matrix, 2, 1, 3, 2. So it's going to be 4, 2, 6, 4. And then 3B, going to multiply matrix B by 3. So -2, -2, 3, 2. So I'm just copying matrix B down first before I multiply it. So 3 times -2 is -6, -6, 9, 6. And then we'll add them together. So 2A plus 3B. So our 2A matrix is 4, 2, 6, 4. And then we're going to add that to -6, -6, 9, 6. So 4 minus 6 is -2, 2 minus 6 is -4, 6 plus 9 is 15, and 4 plus 6 is 10. And there you go. All right, so matrices aren't that difficult, and if you do further maths, you're probably doing matrices. So we're going to see it quite a bit when we do transformations, and I'll also show you how to solve, no, sorry, not how to solve simultaneous equations, although you can solve simultaneous equations with matrices, but you're not expected to do it in methods. But you can use matrices to work out how many solutions you have. So whether it's a unique solution, no solution, or infinite solutions. All right, I think that is it. Awesome. Bye.